officially, this says graphs of sine and cosine. If you want to know officially where we are according to the book, we are in lesson 4.4. So if you get confused, if you get curious, and you start going to the book looking for help, you're going to want to go to lesson 4.4. As I said, we're going to be doing the worksheets on this, so I'm not going to be assigning problems from the book or anything for the next week or so. So your books can probably hang out in your locker or wherever, and you'll be fine. Or wherever they are already hanging out. Now, these are graphs that you pretty much need to memorize. You know, kind of like when I say parabola, you guys know a parabola is the U shape, right? There's certain graphs that you know. Sine and cosine need to fall into that category of certain graphs you know. Yes, technically you could graph something like this on the calculator. However, the details that we are putting on our graph are going to be hard to glean from the calculator. Does that make sense? Okay. So when I'm grading, as I said, I'm going to be looking for certain details that you can kind of check yourself a little bit on the calculator, but I need to see certain pieces here. So you'll notice both sine and cosine. If we start with the range, they both go as low as -1 and as high as 1. Okay. So the basic sine and cosine go as low as -1, as high as 1. They both have a period of 2 pi, meaning between 0 and 2 pi, we have one cycle of the graph from 0 to 2 pi. Now, what happens at 2 pi is my graph starts over. So these graphs are going out infinitely. So if you look at sine, it starts here at 0, 0, goes up to 1, cuts through pi, cuts through 2 pi. So what's going to continue happening? It's going to go up to 1 again. It's going to cut through 3 pi, go down to -1, cut through 4 pi. And it's going to keep repeating that cycle infinitely to the right and to the left. Cosine, same thing. The difference is it starts at a different place. It starts up here at 1, cuts through pi over 2, bottoms out under pi, cuts up through 2 pi. So if this one continues, it's next going to be under 3 pi and tops out above 4 pi. So on, so on, so forth. If you graph these on your calculator, you're going to see them go on and on and on. I will say if you graph something like this on your calculator, you're going to have your best luck being in radians mode because we're using a trig function. You'll want to make sure you're in radians mode if you're trying to look at something on the calculator. If you're in degrees mode, I'm not going to say it won't work because sometimes it does randomly work, but I wouldn't necessarily count on it working. So just kind of a helpful thing there. So, and I will take you through the graphing and everything. You won't ever just see me write one out randomly, say, okay, there's my graph. I'll break it down with you. But notice my sine. I kind of break my sine up into 2 halves and then 4 pieces. Because if you go, pi over 2 is a half pi, right? So this is 1/2 pi, 1 pi. 3 halves is 1.5, right? 2. So you'll usually see me break it out. From 0 to pi, the first one, we have the mountain. From 1 pi to 2 pi, we have the valley. You'll notice that it maxes out above at the midpoint. So it maxes above pi over 2. It has a minimum below 3 pi over 2. Over here on this one, it starts maxed out at 1. It cuts through pi over 2. It bottoms out below pi. Cuts back through 3 pi over 2. Maxes out above 2 pi. Those are some details I'll be looking for when you draw these graphs. Okay? Now, needless to say, I'm not going to just say, okay, draw sine x for me. Draw cosine x for me, and we're done. That would be way too easy. Okay? What we've got to look at is we're looking at all of our transformations of our graph. If you go back to like what I teach in Algebra 2, we have translations, right? Shifting them left, right, up, and down. We have stretches. We have shrinks. Okay, we have reflections. It's all that stuff. Except our vocabulary when we work with these trig graphs is slightly different. So, if you look down below here, you will see a basic setup. Okay, the pieces we will possibly be looking at is a form could be either a sine or a cosine graph for today. There's a possible A value out front, Notice, what does it say A is? A is the amplitude. Okay, so it's the positive value of A, but it is the amplitude. How far above and below the center line to count. So, do you guys remember from Algebra 2 what a number out front when it's multiplying? When it's multiplying, it is your stretch or shrink. That's what this is. Okay? Again, vocabulary is slightly different, but this is your vertical stretch and shrink. For the trig functions, though, we're going to talk amplitude. That says vertical stretch slash shrink, if I can get it zoomed out. Next thing we're going to talk about is a period. Okay, I think you guys heard me mention cycle or period at the beginning. The traditional cycle or period of cosine and sine is 2 pi. Equivalent to once around the circle, yes? So 2 pi is your traditional, a normal period or cycle. Now, our period may change based on if there is a b value. So a b value would be a coefficient of x. So if your x has a coefficient, then you're going to use that, do 2 pi divided by b, and that will be your period. Okay, that will be the length of one cycle. So instead of your length of a cycle being 2 pi, it could be longer, it could be shorter. This is equivalent to what we did earlier this year with horizontal stretch and shrink. Okay, I don't think we talked about horizontal in Algebra 2, but we talked about this year. So this is the idea of horizontal stretch and shrink. Okay. C over B is what will tell us our phase shift. Notice C will be a number added or subtracted in the parentheses. B is that coefficient of x. So C divided by B will be your phase shift. This will put your graph in the correct location, as in this is your horizontal translation. Okay, this is how far left or right my graph goes. Previously, you can tell left or right by looking at what's added or subtracted in the parentheses. Yes, other than you have to pay attention to if there's a b value, you divide by that. So this is my horizontal translation. Okay. D, so that's that number added or subtracted at the end. That is what we're going to call, it's going to label our center line. Basically, it's going to tell us how far up or down our graph moves. Now, the key is, we're not going to really move our graph up and down. What we're going to do is we're going to label our center line differently. Okay, because we want to keep it on that center line just for ease of graphing. But this is really, if you connect it to what we've done previously, it's the vertical translation. Okay, and one thing that hasn't changed, what's the negative out front of a graph do? It's going to flip it. It's going to be a reflection. So a negative a value up front will flip the graph. Or in other words, there will be a reflection. Okay? So those are all the pieces. As we look at these graphs, I'm going to take you kind of through the process I go through. I know you guys will all kind of tweak your process as you figure more of this out, but so let's look at example 1. Example 1 is y equals 3 sine of x minus 4. Now, one of the first things I'd like to ask, which graph is this? Is this sine or cosine? Okay. I know it's a silly question, however, I know, you're like, really? Yes, that is because you have to recognize when I go to draw this, am I starting in the middle and going up and making a mountain and a valley? Or am I starting at the top of a mountain and going down and coming back up? Which graph does this look like? So, first thing I'm going to pay attention to is the fact that this is a sine graph. What's a sine graph look like? Starts in the middle, makes a mountain, goes back through, makes a valley. Okay, that's not the greatest picture right there, but that's just kind of what my brain's thinking right now. Is, okay, this is a sign graph, this is what I'm going to draw. Okay. Two things I always like to start off asking. Center line. Where is my center line? -4. Because my center line is defined as D, which is a number added or subtracted on the end, yes? So my center line is -4. What that means is that officially my graph is going to move down 4. But instead of me physically moving my graph down 4, I'm going to relabel my center line. Okay? I'm not going to call my center line 0 anymore. I'm going to call it -4. I'll go ahead and put it on here, I guess, while we're talking about it. You can either label it right there, or if you want to try and squeeze it in right there. After center line, I like to talk amplitude. What do I have in the way of amplitude? 3, because amplitude is my A value, and my A value is 3. Okay, that's how far above and below the center line to count. Okay, how high and low does my graph go? That's what this is asking. And so what we're just saying is my graph goes how high and low? Goes 3 high and low, which means it goes 3 above my center line and 3 below my center line. So a normal graph goes 1 above my center line and 1 below my center line, if it has no stretch there, if it has no amplitude. This is going to, since I have an amplitude of 3, I'm going to go 3 up and 3 down. Meaning, so what's my center right now? My center is -4. How high do I go if my center is -4 and I'm going to count 3 up? -1. How low do I go if I'm going to go 3 below -4? -7. These are some of the easy points to get on your graph, but I will be looking specifically for those labels. A center line of -4 can be labeled out here or labeled right there. And the fact that my graph goes as high as -1 in this case, because that is 3 up, and as low as -7, because that is 3 down. Okay, we've talked center line. We've talked amplitude. Another important thing we need to talk is period. What is the period of this graph? So how is period defined up above? 2 pi divided by b. Where's b? Coefficient of x. What's my coefficient of x? 1. So my period, I mean, if you really want to go there, it's 2 pi divided by 1. But in other words, my period is just the traditional 2 pi. That means one cycle of my graph is going to fit in 2 pi. That means, as this first example goes, I don't have to shorten my cycle or make it any longer. It's just going to be as is. Okay? And then, we never had a negative A value to talk about. Phase shift. What do I have in the way of a phase shift? C over B. C over B are numbers that are with the x. Do I have anything with the x? So I have no phase shift to worry about. Because there is nothing added or subtracted within my parentheses. There's no phase shift, so there's no movement left or right. We'll add that in later is what it comes down to. Okay, so we know how high and low my graph goes. A period is 2 pi. So that means your minimum requirement is to draw one cycle of this graph. Okay, you can technically keep going and draw more, but minimum requirement is to draw one cycle. So 1 cycle is 2 pi. That means I'm going to need to label my graph from 0 to 2 pi. When I label this, what I tend to do is I tend to use a lot of my graph, and I kind of start out and work my way in. If my period is 0 to 2 pi, where's the middle of this? What's in the middle of 0 and 2 pi? 1 pi. So if I already have 0, I labeled 2 pi, I'm going to approximate my middle, and I'm going to label it pi. You minimum have to take this space and divide it into 4 pieces. Right now I've divided my space into 2 pieces. So now I have 1 pi and 2 pi. What are the halfway points here? Yeah. 1/2 and 1.5, right? So the halfway point between 0 and pi is 1/2, or pi over 2. The halfway point between 1 and 2 is 1.5, or in other words, 3 pi over 2. This one may not strike you as hard, but that's probably one of the hardest things we have to do is being able to label there. Okay? Now, we're ready to graph. Okay? There's certain points I'm going to want to make sure that you guys hit. So, this is a sine graph. Where does my sine graph start? Normally we would say 0, 0. In this case, it's going to start here at 0, -4 technically. Okay. Where does the sine graph go? It goes up, and it's going to max out over that 1/4 of the way through my problem. So in this case, we're going to max out above pi over 2. How high should I be above pi over 2? Where is your -1 label? That's where you should hit. Now, what do I do next? I'm going to cut through the middle. My middle is pi. So I'm going to cut through pi. And I'll come back and connect this all in the end. After I cut through pi, what's my next marking point? We have to bottom out under 3 pi over 2. Now, when I bottom out under 3 pi over 2, how low should I go? You should be at -7. So wherever you marked your -7. And then what's the last thing I have to do? I have to cut back through 2 pi. So, notice, I like to make these little marks. It kind of helps me have, I can see where I'm going. Officially, you can put arrows if you want. They do keep going. I don't know that I have to have the arrows necessarily. Now, you guys know I'm not looking for perfection. Okay? But there's some things, there will be pieces I'll be looking for. Does it look evident that you tried to go as high as -1 and as low as -7? Or did you make those marks and then not pay attention to them? Okay? You laugh, but it's true, because some people will make those -1, -7, but then when they draw their graph, they don't pay a bit of attention to hitting those spots. Okay? The other thing, your sine curve it's a curve, yes? Those aren't points. This is not absolute value. Try and make them a little curved. Some success? Okay. Let's try number 2. If I go with, I have 1, 2, 3, and 6 planned, I think. Not that can't change, but. Okay. So, let's try and make sure hopefully we'll get through this. Okay, things to think about. What graph am I going to be drawing? We're going to be drawing a cosine curve, yes? What does a normal cosine curve look like? Starts high, goes down. It's a big old valley, yes? That's the idea of what my normal cosine curve is going to look like. Okay. What are some pieces we see here? We kind of, to an extent, start in the same order. Let's talk center line. You guys agree with the center line of 1? Okay. If you want to go ahead and label that, how do we label a center line of 1 on your graph? You can either label it down at the very left or label it right there in the center. Okay, and that's because that's that number add, subtract at the end. Amplitude. Amplitude is what? 2? Okay, so if you look, officially it says amplitude is the absolute value of A. A is the number out front of cosine. So my amplitude is 2. What does that 2 mean? An amplitude is how high and low my graph goes. So if my graph goes up to and down to, what am I going up and down to from? 1. So when I count 1, 2, what is up to from 1? 3. If I go down to, what is down to from 1? -1. So do you see those marks? Now, I was specifically told the amplitude is 2. What else do we need to consider while we're talking about that amplitude? It's negative. What's that negative mean? There's a reflection. It's a reflection across the x-axis. What's that going to do to my graph? It's going to flip it. So instead of it being a valley like we thought it was going to be, it's going to be a mountain, a hill. Again, I'm just putting the picture for a visual. Let's see. Period. What do I have in the way of a period? It's 2 pi divided by b. Do I have a b this time? I do. My coefficient of x is 2. So 2 pi divided by 2 is what? Pi. So pi is 1 cycle. So my cosine graph that normally goes from 0 to 2 pi is now going 0 to 1 pi. So I'm shrinking it. Okay? Phase shift. Do I have a C value? Do I have anything added or subtracted in the parentheses? No, so no phase shift. Okay, so when I labeled it this time, I need to label from 0 out to pi if I'm just doing 1 cycle. Now, if you want, you could take the pi and stretch it all the way over here and put it all the way over where 2 pi was on the other graph. Okay, and what that's going to do is cosine curve is still going to look normal. It's just going to be labeled differently. What I'm going to do to kind of try and show you the stretch or the shrinkage here is I'm going to label that pi. Now, what's halfway in between 0 and pi? 1/2, so pi over 2. How many pieces do I want these graphs divided up into? I like to see fourths. So, what are the middles here? What's halfway in between 0 and pi over 2? Or in other words, what's halfway between 0 and 1/2? 1/4 or pi over 4. So think about it. This is 1/4. Pi over 2 is 2/4. What comes next? 3/4. Think about it. Does that count right? 1/4, 1/2 is 2/4, 3/4, and then 1 is 4/4. Okay. Now, a cosine curve. Where do I start? Normally I start at the top, but this one was reflected, so I'm starting where? At -1. Okay, so think 4 pieces. With a cosine curve, you start either high or low. This time we're starting low. First thing we're going to do is we're going to cut through. So where am I going to cut through my axis? Pi over 4. So your fourth of the way through your graph, you cut through. Halfway through the graph, what are we going to do? You're going to top out. You're going to max out. That was halfway through the graph. 3/4 of the way through the graph, we're going to cross back through the x-axis. And then at the end of the graph, we're going to have a minimum again. So, do you see how I can connect my points? Okay. Did you use your 3 and -1? Or did you ignore them? Okay. Make sure you use them. That you use 3 as your max, -1 as your min. Did you cut through pi over 4 and 3 pi over 4? Okay. Did you max out above pi over 2? Those are things to check. Okay. As much as I would like to go on, we would get caught in the middle of another thing, another graph. Now, here's the deal. We have not talked about phase shift yet, have we? Okay. And I think we would have probably been okay had I not wanted to get you guys signed up for the field trip, but since that came out last night, I wanted to get it done. So, homework, I'll go ahead and give you the worksheet. It will not be due tomorrow because I haven't done any phase shifts with you, and it's a little tricky while you're learning it.